Okay, so there were some questions about the Z formulas that were presented in this chapter 7 versus the one in chapter 6. And let me get my mouse back. So in this chapter, we are looking at this equation here, where we have Z is equal to X bar minus mu over sigma divided by the square root of n. And in chapter 6, we had X minus mu over sigma. And people want to know, well, what's the difference and how do I know when to use which one? Well, what I tell people is this is the one you always use. Okay, because the difference between these two is that this is a single item. Well, the average of a single item is the number. And if I divide by the square root of n, in this case 1, I get 1. So if n is 1, we can still use this formula because we take the average of all the things in there and we get this value. And when we take the square root of n, we get 1, which disappears. So I wanted to just show you a sample, and I took some President's heights because it was readily available, and I have a full population, so I can easily do the math. Now, so here I have an Excel spreadsheet with all of my President's heights. I found the population mean, I found the population standard deviation, I picked out a random height for one value, and then I picked out 9 presidents and found the average of those heights randomly. So if I were to put these into formulas now, I would then say, okay, my first one, where I have Z is equal to X minus mu over sigma, I have only looking at one value. I have 192 minus 179.8 divided by the 6.8 here. So I would have, where's my pen? Let me get a new one here. Using this one, I would have, oops, what was it again? Was I need to get my graph back. 192, 179.8. Okay. So I have 192 minus 178 point, I think it was 9. Or was it 179.8? You have to remember those, right? 179.8. 179.8 over 6.8. Okay, if I were to plug it into this formula, I would still have 192 minus 179.8 over 6.8 divided by the square root of 1. So you can see there's no difference in these two formulas when I'm using a single digit. Now, when I'm looking at the large group and I'm taking a sample, that's when I have to use this because it becomes important. The Central Limit Theorem says that as we take more and more averages, we would become normal. So the question was, well, gee, how do we, when it's in the chapter, it says, well, we don't necessarily know what the distribution is going to look like. Well, if we keep taking averages, we know that it's going to become normal. So that's what allows us to use the Central Limit Theorem. It allows us to use this on any distribution that we come across. So what we're doing here is, and we know that the averages of those averages will tend to come towards the mean. So if I took 1,000 averages, of 9 values, and I put them in there, my average of those averages would come close to this value here. In my one sample that I have an average of 177.3. So notice that my single score, I had 192, but when I took 9 values, I had 177.3. 179.8 over 6.8, and now I'm going to divide by the square root of n, which is 9. So the reason I picked 9 because it's nice and easy. I get a simple value, and I would use this and I would calculate my z-score, okay, for this. So in essence, you really only need to know this bottom equation. This is the one to remember, right? Always use it. If I have one value, my mean is going to be just that single value, so I don't have to worry about it. Okay, I hope this cleared a little bit up on the difference between these two. And I'm going to show it to you again in class, but I wanted you to see it beforehand just in case. See you Saturday. Good luck.